This video gonna prove a theorem and then two very quick corollaries to the theorem. It says that if AC is congruent to BC mod n and the GCD of C and n is D, then A is congruent to D. A is congruent to B. That is, in a way, you could cross off the C's. The only difference is that you have a different mod. It's mod n over D. Okay, so let us prove this. So we have that AC is congruent to BC mod n. That implies that AC minus BC is equal to a multiple of n. Okay, now the GCD of C and n is equal to D. Well, that implies that D divides C and D divides n. But that implies, this one implies that C is some multiple of D, and this implies that n is some multiple of D, where the GCD of R and S is 1. Now, it makes sense for the GCD and R and S to make 1, to be 1. Because D goes into C and D goes into N. D goes into C R times, and D goes into N S times. Now, if these numbers had anything in common, maybe they both had 4 in common, well then this wouldn't be the right value for D. D is the largest common factor for both of these. R and S can't have any common factors. If they did, then you didn't use the greatest common factor. That is why R and S have only 1 as its common factor. Okay, so what does that mean? So we're going to work with this equation right here. We can factor out a C. So we know that C times A minus B is Qn. But C is RD. So we have RD times A minus B is Q times N. But N is SD. And it turns out that both sides has a factor of D. We can cross out D. So what we have is R times A minus B is QS. Well, that means that S divides R times A minus B. But R and S have no common factors other than 1. That implies that S divides A minus B. Okay, S divides A minus B. Now the question is, what is S? S is N over D. Well, S is N over D. And exactly what do we want to show? That A is... So, what this tells me is that A minus B is some multiple of S. That implies that A is congruent to B mod S. but S is N over D. A is congruent to B mod S, which is N over D. And this N over D makes sense because D divides N. That is, this here is an integer. Okay, so let's erase this. We have the result of the theorem. We have the result of the theorem. This theorem says that, well, let me just move away anything and everything that I wrote on it. Okay, that's what the theorem says. Now, here in the first corollary, the only difference is that for the if part, the only difference is D is 1. Okay? And for the then part, if D is 1, then this should be N. N over D is 1. But that's exactly what I got, and that completes the proof. The proof is just let D equal 1 in the theorem. Okay, that's the proof. Just let N equal, well, I didn't say D. Just let D equal 1 in the theorem. That's all that happened for the if part. The only thing that's different is D is 1. It's exactly the same. Character for character. Except D is 1. So in the conclusion, I put 1 for D. D over 1, N over 1, or N over D, which is N over 1 is N. Okay, now, what's going on here? In the second corollary, we're given this, which is the same. It has that part where N is P. Just alphabet soup. N is P. Well, P does not divide C. The only factors of P are 1 and P. But P doesn't divide C. That is, when it comes to C, it doesn't have P as a factor. That means the only common, now, every number has a factor, or one divides every number. One is a common divisor for any two numbers. So the only divisor of P other than P itself is 1. So that means that since P is prime, that means that the GCD of P and C is 1. Now, I just want to write it like I did in the last one. I wrote C first. The GCD of C and P is 1. That's what this means. It means that. This here in red, it means that the GCD of C and P is 1. But now, other than N being P, this is exactly what the second corollary is saying. Remember, I can get rid of this and replace it with that. So then, we're going to get the same conclusion. The only difference is instead of N, we put P. And there it is. So P divides C, P does not divide C, and P is prime. That just means that C and P, they have only one as a common divisor. In fact, it's its greatest common divisor. That completes the theorem along with the two corollaries. If you like watching videos like this, subscribe to my channel. It's a cool channel. See you guys in the next video. As always, watch and learn.